Hello. Now, continuing our work in algebra, we're looking at manipulating formulae. And this is just where we have equations that mostly involve letters, and we aren't going to sub in for those letters. We're going to have to do some rearranging of our equations just using letters. Now, if we have an equation that comes from physics, this is the distance equation that we would deal with a lot in physics or applied mathematics. S is equal to ut plus a half at squared. If I wanted to rearrange that to know what a was equal to in terms of s, u, and t, we're going to walk through how it is we would do that. So I want to isolate a, essentially. So what I'm going to do is subtract ut from both sides. S minus ut is equal to a half at squared. I don't want this half here. Generally, I want to get rid of fractions. So I'm going to multiply both sides by 2, which is the lowest common denominator. So I have a denominator of 1, 1, and 2. I'm going to multiply both sides by the lowest common denominator. For simple fractions like this, that's usually the best way to handle things. So I have 2s minus ut is equal to a t squared. And then I have a multiplied by t squared. I don't want that. I want a by itself. So I'm going to divide both sides by t squared. So therefore I get a is equal to 2 on s minus ut all over t squared. And that's a perfectly acceptable final answer. So all I've done is my normal work with equations. It's just that I've left the letters in. I didn't substitute in numbers. But other than that, the work of rearranging our formula is exactly the same as it usually is. A slightly more complicated version is, this is again a physics equation. This is for the object distance, image distance, and focal length of lenses and mirrors. 1 over u plus 1 over v is equal to 1 over f. And we're going to rearrange this formula to get u equals everything else. So again, I don't like fractions. There are multiple ways that I can get rid of these fractions. The way that I'm going to point out to you is that if we write a single fraction equals a single fraction and then multiply both sides by the common denominator. So we have I want to add these two together, so they must have the same denominator. So I must multiply here by v over v and here by u over u. So I end up with v plus u all over v u is equal to 1 over f. Now I want to multiply both sides by my lowest common denominator, which is going to be VUF. That's the lowest common denominator. So I'm going to multiply both sides by that lowest common denominator, and that because I'm making both sides bigger by the same amount, I'm not breaking my equality. So when I do that, v and u divide out to 1 on the left-hand side, and f divides out to 1 on the right-hand side, and I am left with f multiplied by v plus u is equal to vu. Now I want to get all of the u's by themselves, so I'm going to multiply that out. So I multiply out my bracket and I get f, or vf plus uf is equal to vu. I want to get all of the stuff involving u together, so I'm going to subtract uf from both sides. Vf is equal to uv minus uf. Take out my common factor of u because I want to isolate u. V minus f. Now I divide both sides by Vf to get u by itself. And I end up with u by itself is equal to the rest of my materials, which is what I was looking for. So you can see the rearranging is no different than anything you've already known for many years in terms of rearranging equations. It's just that we're going to have more letters involved. Now, in terms of a problem, a more exam-style problem that they might ask that would be similar in tone to this, if we had a semicircle on the hypotenuse of our right-angle triangle here, sorry, that should be a right-angle triangle written in there. We have a semicircle on the hypotenuse of a triangle, and we have a semicircle on the side of a triangle, and we want to show that A2, the area of our semicircle on the hypotenuse, is twice the size of A1, the area of the semicircle on the side of the triangle. And I have a few things that I note here. I have a right angle triangle. I'm dealing with sides and hypotenuse, so I'm immediately thinking I've probably got Pythagoras to deal with here. I can see that I have my marks here, which means that these two sides are the same length. So that immediately means I can write down that this length is also 2x because I'm given this length as 2x. And I would automatically know that these angles here were equal and must be equal to 45 degrees. I know all of that, and that's all junior cycle stuff. There's nothing that there's nothing higher level leaving cert that we're talking about there. And here we have, if we rewrite this question in terms of mathematical language, show that area 2 is twice the size of area 1. So that means that A2 would be equal to 2 times A1. Area 2 is twice the size of area 1. So that's what we're looking to show. Well, how would we get the area of either of our triangles, of either of our semicircles, I should say? Well, the area of a semicircle, the area of our semicircle is half the area of our circle. And if we go to page 8 in our log tables, or if we remember it, pi r squared is the area of a circle. So half of that is going to be the area of a semicircle. So we have the area of A1 is going to be a half pi times r squared, where r is going to be, well, the diameter of my circle is 2x. So the radius is going to be half of that. It's going to be half of 2x. It's just going to be x. So area 1 is going to be a half of pi x squared. That's fairly straightforward. I haven't had to do too much rearranging there. But I want to know what the area of A2 is going to be. So I have to think this out now. The hypotenuse is its diameter, and I want the radius, so I can get the diameter first. So if I think back to Pythagoras, I have h squared is going to equal a squared plus b squared. Well, in this case, h squared, my a squared and b squared are 2x in both cases. So I end up with 4x squared plus 4x squared. So h squared is equal to 8x squared. I want to know what my hypotenuse is, what the diameter of my circle is, not the square of it. So I'm going to get the square root of both sides. The hypotenuse is going to be equal to 2 root 2 x. Now, an important point, I don't need to worry about the fact that this is technically plus or minus a square root because I am dealing with a length, so I am only worried about the positive result. I don't deal with negative lengths for most of my work in mathematics. So that's why I don't need to put a plus or minus here, because h is a length and we generally only deal with positive lengths. So I now know that the hypotenuse of this is going to be 2 root 2x. So then for area 2, I'm going to have same deal as before, a half pi r squared, but this time r is going to be equal to 2 root 2 x all over 2 is going to equal root 2 x. I sub that in. Area 2 is equal to a half pi on root 2 x to be squared is equal to a half pi on 2x squared is equal to 2 divided by 2 is 1, so I'm left with pi x squared. So pi x squared is twice the size of a half pi x squared, therefore, so as pi x squared is equal to twice a half pi x squared, therefore a2 is equal to 2 times a1, which is what I was asked to show in the question. So what did I do? How did I approach that question in terms of if I'm coming to it in an exam? Well, before I really thought about the question very much, I looked at the picture that I'd got and I wrote in all of the information that I knew. I didn't actually end up needing the 45 degrees information there, but there was absolutely no harm in writing it in. It meant that I was writing down all of the different tools that I could see were available to me. I also recognized that I had my right angle triangle and I was looking at sides of things, which almost certainly meant that I was going to end up dealing with Pythagoras. If I'm dealing with the sides of right angle triangles, I'm almost certainly dealing with Pythagoras. I saw that I had semicircles involved in my question within my ability to draw them, which meant that I knew that I was going to page 8 in my log tables and I was going to be looking at the formula connected to the area of semicircles, or having the area of a circular disc in this case. So those are all of the different bits and pieces that I had. And once I'd written them down and thought about them for a moment, once I knew what tools I had available to me and what information I had available to me, it was fairly easy to figure out to make a first step. And if we're thinking about our marking scheme, if this was an exam question, getting the area of my area 1, which required very, very little algebraic work, would be 4 out of 10 marks. So we're already passing the question by the time we get this kind of work done if we've gotten the area of something. So if I can write down the information I know and sub in to any formula that seems relevant, I'm getting myself up in the attempt marks. So there's never an excuse in maths for leaving a question blank. I'm always looking to increase the amount of marks that I can get, even if I'm not sure of what to do with the question. So if I see a shape that I know formula for, like right angle triangles often mean Pythagoras, or if I see a semicircle, I'm going to write down the formula for the area of a semicircle. If I do those things, it will help me to answer the question, to figure out what I need to do, but it will also be working me towards attempt marks in my final exam. So that's my methods and thinking for manipulating formula.